All right, what we're going to look at here is a little game plan for using either a computer program or a spreadsheet to calculate how something is going to move or to run like a little physics simulation. Could even use this as the physics engine of a little video game that you program or something. And so what you do is you set up either, like I say, a spreadsheet or arrays where one column is the position, one is the velocity of an object, one is its acceleration, then you give time and a time step. And so what happens is this first little cell here is the initial position. So you basically say where an object starts. So you decide that an object exists and it's at this location. All right. So you basically say where the system starts. And then you have to establish some sort of initial velocity, say whether the object is moving or not at the very beginning. So you say how fast the thing starts moving. Now this box that's kind of in bold here is really where all the physics is going to go. And so given where an object is and how fast it's moving, in order to calculate what it's going to do next, we need to learn how it's going to accelerate. Well, accelerations, of course, are caused by forces, and you can calculate the acceleration by dividing force by mass. Now the beauty of this is that the force on an object typically depends on where it is, and how fast it's moving, and might be time dependent. Okay, so all the physics really goes in here. If this is a gravitational force up here, near the surface of the Earth, you might put mg. If it's planetary gravity, you can put that in. If it's attached to a spring, then the force on it would be negative k times its initial position. And likewise, if there's wind drag acting on it, then the force depends on the velocity. But in any of those cases, or maybe all of those things are happening at the same time, you can calculate what the force is on it that instant, and that gives the acceleration at that instant. Okay, so all the physics goes here. Then what you do is define a time step, like let a little wiggle in time go by, right? So after, say, 2/100ths of a second go by, I'm just making up that amount of time, what we need to do is then update, okay, after that amount of time goes by, how fast is the thing moving and where is it? Well, so the scheme here is you pretend that this acceleration is actually constant over that next 2/100ths of a second. So you say that the new velocity equals the old one plus the old acceleration times a change in time. And so if you were writing that in a spreadsheet, that would be like equals b2, which is your initial velocity there, plus c2, which is your old acceleration, times the change in time, which is going to be 0.02 seconds. And so you kind of keep that fixed or call it with dollar signs. So you're always calling this box. All right. And so then you update the velocity. Right. So again, that just comes from the data that's above it. Right. To update the position, you can do the same thing. You just do some kinematics. You pretend that this thing is constant. So the new position is going to be the old one plus v initial t plus 1/2 at squared. And so you're just calling information from the row above, and that gives you the new position. So again, writing it in spreadsheet notation, there's your initial position, initial velocity times your wiggle in time plus 1/2 AAT squared. All right. Well, once you've updated the position and the velocity, that allows you to update the acceleration. So now we're actually able to update that. You're able to update what has happened with the force, and that gives you a brand new acceleration. The acceleration has changed. Okay. Well, so the acceleration just changed, and so we're going to use that as the acceleration for the next row. And so the idea here is once you got this far, you could just highlight this entire row of your spreadsheet here, row 3 here, and then copy it down into the future, and that's going to tell you how this thing's going to move. And so again, just to see how it plays out when you do copy that down, based off of that updated acceleration, you'll get the new velocity by saying it's going to be this velocity, the velocity from this box, plus the new acceleration times time. So when you copy the formula down, this will be now b3, which is this velocity, plus the new acceleration times the wiggle in time. So that updates the velocity. You can update the position in the same way. And then from the updated position and velocity, you can update the acceleration and so on. And so then that perpetuates like out into the future. So that's a little schematic for a little game plan anyway for calculating how something's going to move, subject to forces that depend on, say, position, velocity, or even time. you would put that in there and just simply update the acceleration. The approximation that's made here is we're assuming the acceleration is constant over a short time window. So if you want this simulation to be more accurate, you just shrink the size of the time window. So I hope that helps. Again, you can use this in spreadsheet format, or these columns can basically turn into arrays if you're a programmer, and then you could probably animate your results.